Let's consider this question on indices. This question says if 9 raised to the power of square root of n is equal to 27 raised to power n, or square root, find the value of n. Now, if you look at 9 and 27, they can be expressed to a base of 3 so that we can equate the exponent, the power. What are we going to do to 9? 9 can be expressed as 3 raised to the power of 2. What about 27? 27 can be expressed as 3 raised to the power of what? 3. Because 3 times 3 times 3 will give you 27. And here, 3 times 3 will give you 9. So let's come here and do this. So that's going to be 3 squared. Okay. Then we still have the square root of n here, which is equal to, what about 27? It is now 3 raised to the power of 3. Then the power of n here. But this square root has to be out of here so that we can just easily equate the exponent, the basis of 3. Now, one of the laws of indices, if you have the square root of a, for instance, this can be expressed as a raised to the power of 1 over 2. This is what we call fractional index. 1 over 2 is a fractional index. So if you have a raised to the power of 1 over 2, it can be expressed as the square root of a. So that's exactly what we're going to do here. I'm going to write it as this. So this is 3 raised to the power of 2 root n is equal to 3 to the power of 3n. Now, what about this square root? It will now become half. That's the power of half here. So that's times 1 over 2. So let's continue from here. Now that we have a common base of 3, I'm going to equate the exponent. That will be 2 square root of n, which is equal to 3n times 1 over 2 is 3n over 2. Okay. But here we have the square root of n. What do we do to get rid of this square root? I'm going to square both sides. So let's apply the square to both sides. Now, this is affecting both 2 and root n. So that's 2 squared times root n squared is equal to, what about this now? This square is affecting 3n and 2. That will be 9. 3 squared is 9. Then you have n squared over 4, not 2, but 4. So if you do this will be 4. Then this square root will get rid of this. The square will get rid of the square root. So that would be 4n, which is equal to 9n squared over 4. So what do we do next? Let me cross multiply. So like this. 4 times 4n is going to be what? 16n, which is equal to what? 9n squared. So let me move 16n to the right hand side. Okay, so it's going to be 9n squared minus 16n. Okay, so which can also be expressed as 9n squared minus 16n is equal to what? 0. That we see, I just flipped it. So look at these two terms. Let's factorize now, because we need to get the value of n. Now, because we have, this is a quadratic equation, we're going to have two values of n. So if I factorize this, n is common. I will be bring out n. This will be 9n minus 16. Okay, which is equal to what? 0. So we're going to use the zero product rule, because n bracket 9n minus 16 is equal to 0. It means that either n is equal to 0 or 9n minus 16 is equal to 0. So that would be n is equal to 0 or 9n minus 16 is equal to 0. So n is equal to 0, or if you move minus 16 over to the right hand side, it's going to be plus 16. Divide both sides by 9. Since I'm trying to get the value of n, 9 takes away 9, and this becomes n is equal to what? 16 over 9. Now you can extend this further by saying n is equal to 9 into 16 to go one time with a remainder of 7 then over 9. So these are the values of n. N is equal to 0 or n is equal to 1 over 7 over 9. You can plug it in here, and I'm sure you will get what you get on the left hand side is what you're also going to get on the right hand side. Because of time, I will not be doing that. You can try that out and see if these two values of n will satisfy this equation. If this video was helpful to you, kindly support my work by subscribing to this channel, like it, and share to your friends and family. I'll see you in the next one.